Hello, friends, and welcome to a lecture on mathematics this time. This is Professor Arvind Prasad, and today we will learn how to visually find the sum of n natural numbers. What we'll do is how to sum the first n natural numbers. We'll give a visual proof of that. So there we are. The sum of natural numbers in the RHS is given as 1 plus 2 plus 3 plus, let's keep summing on to the number n. So now let's go to the next slide, and there we are. For this, to visually understand the proof, let us take a triangle which has sides n. That is, its base is n and its height is n. Now let's divide this triangle which is of base n, length n, and height of length n into n minus 1 equal parts vertically. So there we are. Well, on the left hand side, you have the first part of the area, followed by the second part of the area, followed by the third part of area. Now green represents subsequent equal areas, and n minus 1 is the last n minus 1th area. Now, area number 1 is a triangle. It has base of length 1 and a height of length 1. Area number 2 is a trapezoid. It has base of length 1 and heights, that is the heights of the sides, as 1 and 2. That is, they are of length 1 and 2. The trapezoid 3 has a base of length 1 and the sides are of length 2 and 3. We can keep writing this for all the equal areas represented in the green zone, and finally we'll do it only for the last area. Now the last area is the n minus 1th area. This n minus 1th area has lengths of 1, that is, the base is of length 1, but the height of the sides is n minus 1 and n. Now let's have a look at what is the actual area of these areas. That is, let us calculate the areas. Now area number 1, since it's a triangle, it has a base of length 1 and height of length 1. So it's going to be half base into height, that is half 1 into 1. Now 2 is a trapezoid, so it's going to be half the sum of the lengths of the sides, that is 1 plus 2, multiplied by the length of the base, that is 1. Similar thing goes for trapezoid number 3, which can be written as half 2 plus 3 into 1. And the similar can also be written for the last trapezoid which we are going to have. Now this is going to be half n plus 1, n minus 1 plus n into 1. That is because it has the size of this trapezoid has a length of n minus 1 and n. Now what we do is we sum all these areas. So starting from the first area, the second area, the third area, if we sum all these areas, this is going to be equal to the area of the entire triangle. Now let us write this down and logically look at it. The sum of the entire triangle is going to be half n into n, that is half base into height. Now base and heights are of length n and n. This is going to be equal to the sum of the first triangle, which is half into 1 plus the subsequent trapezoids. That is, trapezoid 2 is half 1 plus 2 into 1. Trapezoid number 3 is half 2 plus 3 into 1, so on and so forth till we come to the last trapezoid, which is half n minus 1 plus n into 1. Now let us do some mathematical jugglery. So as we know from the previous slide that the area of the triangle is going to be half n into n, that is half base into height. Now this is going to be equal to the sum of all the areas. Now the first area is a triangle, so this is going to be half of base into height, that's 1 into 1. And the second area is a trapezoid, so it's going to be half 1 plus 2 into 1. For the third area, it could be written as half 2 plus 3 into 1, so on and so forth till the last area, which is half of n minus 1 plus n into 1. Now let's concentrate on the first equation itself. Okay, for the time being, let's take the first equation, which is on your board. Now the first term, half 1 into 1, and in the second term you have half 1 plus 2 into 1, which is half of 1 plus 2. In the first term we have half 1, in the second term also we have half of 1 and half of 2. Now half of 1 becomes 1. So there we are, we come to the equation number 2. The first term here is 1. From the RHS of equation number 1, the first term we get is 1. The second term on the similar lines of argument is going to be 2, because what we have in the second term is half of 2 and we get half of 2 from the third term 2. That's funny. And we get 3 here. And we can keep on writing similarly, and we get half of n minus 1, which is going to be nothing but, n minus 1, which is going to be nothing but half of n minus 1 plus half of n minus 1. And the only term that will remain because of the last term here is going to be half of n, which we write down separately. Now what we do is we take the right hand side of the equation and take the left hand side of the equation number 1 and take the right hand side of equation number 2. Since they are equal, we rewrite it. And we take half of n on the left hand side. So on the left hand side, you have half of n into n minus half of n. If we remove half of n common, right? So what we get is nothing but n minus 1. So we'll get half of n into n minus 1, and there we are. So we get half of n into n minus 1 is equal to 1 plus 2 plus 3, so on and so forth till n minus 1. Now we replace n with n plus 1 in the above equation, and we get what we had set out to prove. Well, this is always, we can do it in mathematics because n is any number. So we can replace it with some any other number, right? N is any number that you can imagine. So I have imagined n as n plus 1. So we replace it in equation number 4 and we get 1 plus 2 plus 3, which is nothing but the RHS of equation number 4 till n, because now n minus 1 in equation number 4 gets replaced with n plus 1. So it becomes n naturally is going to be equal to half of n into n plus 1. Because in the LHS of equation number 4, we replace n with n plus 1. So the first term now becomes n plus 1 and the second term becomes n. So I rewrite it as half of n into n plus 1. This proves that the sum of the first n natural numbers is nothing but half into n plus 1. There, this is the final form in which we write. And that's the end. Goodbye, friends. Have a great time. Have a great day.